In this section, I will derive 4 examples using the definition of derivative. So, what is the definition of derivative? There is actually 2 forms, but they give you the same results. So, the first form is f prime of x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. And the other one is f prime of x equals limit of delta delta goes to 0 of f of x plus delta x minus f of x all over delta x. So either form will work. They're going to give you the same results. I'm going to use the first one because it just seems much easier. So go ahead and pause if you need to copy the 2 forms. Okay, so let's start with example 1. Okay, so example 1. Find the derivative using the definition of derivative. So we have f of x. I know if you have some foundation of derivatives, you'll know that the derivative of f of x is -5, but we specifically wanted to use the definition derivative. So I'm going to use this rule, the first one. Okay, so did you know that we already have f of x? What we need to find is f of x plus h. So let's find that. F of x plus h is going to be, you're going to use this function, and wherever you see an x, just replace it with x plus h. So it would be -5, and then just replace x with x plus h. And if you FOIL that out, that would be -5x minus 5h. Okay, so now we have everything. So now it's going to be f prime of x equals the limit as h approaches 0. And then you can replace f of x plus h with this thing. So it's going to be -5x minus 5h minus, and if you want, you can put a parentheses, minus f of x. So f of x is -5x all over h. Okay, what do you see? You see that this 2 minuses becomes a positive. So now the 5x cancels. So you can say f prime of x equals the limit as h approaches 0 of minus 5h all over h. And then what do you see that cancels the h's? So really you're just stuck with f prime of x of -5. Now, -5, remember, a limit is a y value, so it doesn't matter what your x value is, this is always going to be -5. So your final answer is just -5. Okay, so that was example 1. Go ahead and press pause if you need to copy down. Let's move on to example 2. Okay, so example 2. Let me clear the board. So now we have f of x equals 2x squared plus x minus 1. And the direction says to find the derivative using the definition of derivative. So, I mean, you don't, I'm going to write down the problem for each example. I'm going to write out the definition, but you don't have to. I mean, if you have it in your notes, that's fine. So what do we have? We already have f of x, right? But we don't have f of x plus h. So let's find that out. So really all you got to do is wherever you see an x, you just replace it with x plus h. So it's 2 parentheses x plus h square plus x plus h minus 1. And then x plus h square, I'm going to do the shortcut. The shortcut, it comes from this rule a plus b. I'm not really good at explaining because that's in college algebra, but just know I'm going to use this shortcut. So my a is x, so it's going to be x squared plus 2xh plus b squared, so that's h squared. And then plus, bring this down. And then FOIL out this 2, so that's 2x squared plus 4xh plus 2h squared plus x plus h minus 1. Do you see that you can, is there anything you can cancel or collect? I don't see anything. So now we're just gonna try to put it in the formula. So it's gonna be f prime of x equals the limit as h approaches 0. And then we said that f of x plus h is this whole thing. So that's gonna be 2x squared plus 4xh plus 2h squared plus x plus h minus 1 minus parentheses f of x, right? F of x is this whole thing. So it's going to be 2x squared plus x minus 1. And then it's all over h. So let me put it here. I'm going to simplify the numerator. So the numerator is going to be 2x squared plus 4xh plus 2h squared plus x plus h. And then I'm going to FOIL out this minus. So it's going to be minus 2x squared minus x and then plus 1, right? So if I FOIL this minus distributed, this is what I get. And then it's all over h. Now on the top, is there anything you can cancel? You can, I see. We could cancel 2x squared. What else can we cancel? The x's. And I'm also missing right here, I'm also missing a minus 1, that's why. So this one cancels. So on the top, you should be left with 4xh plus 2h squared plus h, and then all over h. On the numerator, what can you take out? You can take out 1h. So that's going to be h, and then this is going to be 4x plus 2h plus 1 all over h, and then the h cancels. So your final answer is going to be, so it's going to be f prime of x equals the limit as h approaches 0, and then you're just left with 4x plus 2h plus 1. Then what you could do is plug wherever you see an h, plug in 0. So your final answer is going to be 4x plus 2, and then replace the h with 0, and then 1 stays the same. So your final answer is, so f prime of x equals to 4x plus 1. Okay, so that is that example. Go ahead and press pause if you need to write down all the steps. Okay, let's move on to example 3. Let me clear the board. Okay, on example 3, it looks like we have a fraction, but that's okay. So yeah, so here, let me write out the rule again. What do we really need? We need f of x plus h, so let's find that out. So here's our function. All you got to do is replace x with x plus h. So it's 1 over, and then just replace x with x plus h minus 1. And yeah, that's pretty much it. So now we could set it up as f prime of x equals the limit as h approaches 0, and then it's f of x plus h, so it's 1 over x plus h minus 1 minus f of x, which is 1 over x minus 1 all over h. So we have what's called a complex fraction. This whole thing is your numerator. This whole thing is your denominator. So this is your numerator. This is your denominator. What I would do is, to make life easier, simplify the numerator. So on the numerator, we have 1 over x plus h minus 1 minus 1 over x minus 1. So when you're subtracting fractions, you really do need a greatest common factor. So my greatest common factor for the numerator is actually this and this. So it's actually x plus h minus 1 times by x minus 1. So over here, it's missing an x plus h minus 1. Over here, it's missing an x minus 1. So on the top, 1 times that's x minus 1. And then, do you see this minus? Just distribute that minus. So it's going to be minus x minus h, and then a minus times a minus 1 is a positive 1. Okay, so I guess this simplifies as, what do you see that cancels? The x's and the 1's. So you're left with negative h over the greatest common factor, which is x minus 1 times x plus h minus 1. Okay, so this is just your numerator. Then it's let's do that. Let's divide this by h before, yeah. So if I cross multiply, this is going to be negative h, and then on the bottom, if I cross multiply this is going to be h times x minus 1 times x plus h minus 1. And what do you see that cancels? The h's. So you're left with negative 1 over x minus 1, x plus h minus 1. Okay, so now we can finish our problem. So you can say f prime of x equals the limit as h approaches 0. And then this whole thing right here, we simplified as -1, this one right here. So it would be -1 over x minus 1, x plus h minus 1. And then you could just replace h with 0. So it's going to be -1. X minus 1 just stays the same. And then you just replace h with 0. So this is going to be x minus 1. So your final answer should be -1. So you could say f prime of x equals to -1 over x minus 1 times x minus 1, which reality is x minus 1 raised to the second power because they're the same. So that is your final answer. Okay. Go ahead and press pause if you need to copy the work. And let's move on to the last one. Example 4. So find the derivative using the definition of derivative. Like again, I'm going to write out the rule again. Okay, so really what we really need to do is find f of x plus h. So let me find that out. So that's going to be square root, replace x with x plus h, and then there's a plus 1. So you can say f prime of x equals the limit as h approaches 0. And then you can replace f of x plus h with square root of x plus h plus 1 minus f of x, which is square root of x plus 1 all over h. Okay, so what can we do here? Well, if you plug in h, you're definitely going to make it undefined, which we don't want. But I know there's a minus and then there's a radical. I want to get rid of the radical in the numerator. So one way is multiply top and bottom by the conjugate of the numerator. Usually it's the denominator, but in our case, it's the conjugate of the numerator. So the conjugate of the numerator is pretty much itself, but with the positive, with the opposite sign. So it's going to be plus. So it's going to be square root of x plus h plus 1 plus x plus 1. And on the top, if you FOIL this out, what's so significant about the top? It's a perfect square. So really, you can simplify as x plus h plus 1 square, because it is a perfect square, right? Perfect square is a square minus b square. But I'm not going to go too much in depth because that's really algebra. And then minus square root of x plus 1 square. And then on the bottom, it's just h. Okay. So on the top, what happens when you square a radical? It disappears, so you're just left with x plus h plus 1 minus parentheses. And then this, when you square this radical, it just disappears. So you're just left with x plus 1. Then you can FOIL out the minus. So it's negative x minus 1. And what do you see? That cancels the 1s, the x's. So you can rewrite your problem as f prime of x if prime of x equals limit of h goes to 0, and then on the top we said you are left with, what are we left with? 1. Just hold on, let me do this again. So on the top, this is going to be x plus h plus 1 minus x plus 1. So if you FOIL out this minus is negative x minus 1, and then the x cancels, and the y and the 1 cancels. So you're just left with h. So on the top, you're left with h, and then on the bottom, you're also left with the bottom, which is h parentheses. And then the h cancels, so you're just left with f prime of x equals to the limit as h approaches 0. And then on the top, you're left, the h's cancel, so you're just left with 1. Then you just replace h with 0, so it's going to be 1 over square root, and then this is going to be x plus 1 plus square root of x plus 1. And when you finally clean that up, your final answer should be 1 over 2, because you can square root of x plus 1 plus square root of x plus 1. They have like the same base, so it's going to be 2 square root of x plus 1. Okay, so that was the last of the example. So what I would do is, before you take your quiz, do some of the practice problems. Do some of the practice problems homework, and then do the quiz. Okay, so good luck on your quiz. Thank you.